Problem number 14.2. So in an p-type silicon, which of the following statement is true? So electrons are majority carriers, trivalent atoms are the dopants. Electrons are minority carriers, pentavalent atoms are the dopants. Holes are minority carriers, pentavalent atoms are the dopants. So holes are majority carriers, trivalent atoms are the dopants. So p-type silicon, p-type, how, first of all we should know how the p-type semiconductor is formed. So the p-type semiconductor is formed. Let us say we have silicon. Okay, so silicon, so which is having 4 electrons at the outermost shell. So this is also silicon. This is another silicon atom. So the another silicon atom. And these 4 electrons are there. The outermost valence electrons are 4. So what happens here? So it can form 4 covalent bonds. Okay. So this is another bond. This is another bond. This is another bond. So like this. So the structure will be like this. So if you consider, let us say this is the center silicon atom. So let us, so this is another. So like this formation forms covalent bond with the other silicon. Okay. Now what you have to do is, so when p-type material is formed, the p-type material is formed when you are doping with a trivalent atom or trivalent impurity. Impurity means other atom of third group element, like boron. So boron has 3 electrons at the outermost shell. So what we are going to do? So now this silicon is replaced with boron. So what happens then? In the place of silicon, it has boron, which has only 3 electrons, and what it has 4 electrons here. In the place of silicon has 4 electrons, but available electrons are 3 electrons. So what happens is, somewhere from the other covalent bond, the electrons will be getting electrons from the other covalent bond to the this, because so there are only 3 electrons. So in the place of silicon, what you are putting? Boron. Now we have 3 electrons. It needs 4 electrons for the formation of the bond. So for the stability, we require 4 electrons. Somewhere from the in the crystal, silicon crystal itself, it will get electron. So there will be hole formation. Or else you can say, instead of 4 electrons, we have 3 electrons. Other is a hole. So this hole can be filled with other electron from the bond. So that will there exists a hole. So what happens here? In p-type semiconductor, the majority carriers are holes, because here when you observe it, the number of free holes, that is, the number of holes are greater than free electrons. That is, the number of holes are greater than free electrons. So that's why in a p-type semiconductor, holes are majority carriers, and to get the p-type semiconductor, what you have to do? You have to dope with a dope with the trivalent impurity. So the answer is, so when you, so here p-type semiconductor silicon, which of the following electrons are majority? So this is wrong. So electrons are, holes are minority carriers. This is wrong. So these two are wrong. So consider holes are minority carriers. So okay. So this is wrong. Electrons are minority carriers. So this is right. Holes are majority carriers. This is right. Pentavalent atoms are dopants. Trivalent atoms are. This is wrong because pentavalent atom is not the dopants. So you have to dope with trivalent atom. So the answer is option D.